Well, in this session, we conclude our discussion of finding areas by integration. Again, we will do an example using horizontal strips. It's the area bounded by the graph of the parabola y equals x squared and two horizontal lines, y equals 1 and y equals 4. If you draw the graph, the region looks like this. If I try to set this up using vertical strips, I have a small problem. The bottom portion of the boundary has this part of the parabola, then this horizontal line, then this part of the parabola. So I don't get a single expression for the bottom part of the boundary. It isn't really that hard because if I divide it where the equations change, one portion is this, the other portion is this. In the middle I have a rectangle. Area of a rectangle is width times height. The other two portions are mirror images of each other, so the areas are the same. And for this part, I can just use vertical strips. But as you will see, using horizontal strips is a lot easier in this case. Of course, to do horizontal strips, I have to do one small bit of calculation. I have to write this equation in the form x equals something in y. If y equals x squared and I solve for x, I get x equals square root of y, or using fractional exponents y to the power 1/2. Of course, that works only if y is positive. In the second quadrant, where y is negative, I get x equals negative y to the power 1/2. The left part of the boundary is negative y to the 1/2, the right part is y to the 1/2, and y goes from 1 to 4. So if I set up the area using horizontal strips, y goes from 1 to 4, and x goes from y to the negative 1/2 to y to the 1/2 if I go from left to right. So I take the right equation, y to the 1/2 minus the left equation, negative y to the 1/2, and then do the calculations. The integrand is 2y to the 1/2, so an antiderivative can be found by using the power rule. 1/2 plus 1 is 3/2, so an antiderivative would be 2 times the quantity y to the 3/2 over 3/2. Let's simplify this a little bit. 2 divided by 3/2 is 2 times 2/3 or 4/3. Now I can take the net change from 1 to 4. So substitute 4, substitute 1, and subtract. And I will leave it to you to do the arithmetic and verify that you get 28 over 3. This concludes our discussion of finding areas by integration.